This is an audio-visual presentation on vectors. Any quantity that can be represented in the form magnitude direction is called a vector quantity. So with a vector quantity, we have the magnitude and we have the direction. Now let's look at representation of vectors. How vectors can be represented. Now A, we have the magnitude bearing form. The magnitude bearing form. Take note that the bearing is the same as the direction. The bearing is the same as the direction. So we have the magnitude bearing form. An example, we have r theta degrees. Now considering the example, vector AB is equal to 5 kilometers 30 degrees. So when you consider this representation, you can see that we are given the magnitude, that is the distance from A to B, to be 5 kilometers, and we are given the bearing or the direction, that is 30 degrees. So that is the magnitude bearing form. We have the magnitude and the bearing or the direction. Now, when we consider this diagram, we have the y-axis, we have the x-axis. Vector AB is equal to 5 kilometers and the bearing is 30 degrees. Now take note that bearings measure rotation in the clockwise direction from the positive y-axis. Bearings measure rotation in the clockwise direction from the positive y-axis. So given the vector AB to be equal to 5 kilometers 30 degrees, this means that the distance from A to B is 5 kilometers and the bearing is 30 degrees. So now the distance from A to B is 5 kilometers, but the direction or the bearing is from the positive y-axis. So we have 30 degrees up to the line joining A and B. Now we can also represent a vector in the component form as shown. We have x and y. Example, vector AB equals 3, 4. Take note that 3 is the x coordinate and 4 is the y coordinate. So when we consider this diagram, we have the y-axis, we have the x-axis. From vector AB equals 3, 4, the x coordinate is 3, so we have 3 on the x-axis. And the y coordinate is 4, so we have 4 on the y-axis. Where 4 and the 3 meet, that's our point B. So we have the distance from A to B. So we have from A to B. That means that vector AB is equal to 3, 4, where 3 is the x coordinate and 4 is the y coordinate. So that is another representation of a vector in the component form xy as shown on the diagram. 3 is the x coordinate and 4 is the y coordinate. Now let's look at the magnitude of a column vector. The magnitude of a column vector. Given the vector AB equals xy, the magnitude of AB is given by, that's how it is written. This is the representation of the magnitude of a vector. The magnitude of the vector AB is given by the square root of x squared plus y squared. Is given by the square root of x squared plus y squared. That is the square root of x squared plus y squared. That will give us the magnitude of a vector. Now let's look at this question. Find the magnitude of the vectors. Find the magnitude of the vectors. We have AB equals 3, 4. That is vector AB equals 3, 4. And vector PQ equals 2 minus 4. Let's see how best we can find the magnitude of these two vectors. Now solution. Given the vector AB to be equal to 3, 4, the magnitude of the vector AB. Please take note, with the magnitude of the vector AB, we have a vertical straight line before and after the vector. That is the magnitude. That is the symbol. So the magnitude of AB is equal to the square root of the square of the x coordinate plus the square of the y coordinate. So the magnitude of AB equals the root of 3 square plus 4 square. Now 3 square is equal to 9 plus 4 square is equal to 16. 9 plus 16 is equal to 25, and the square root of 25 is equal to 5. This means that the magnitude of AB is equal to 5. Now we consider the vector in II. Vector PQ is equal to 2 minus 4. So the x coordinate is 2 and the y coordinate is minus 4. Now the magnitude of PQ is equal to the square root of 2 square, that is the x coordinate square, plus minus 4 square, that is the y coordinate square. Now 2 square is equal to 4 and minus 4 square is equal to 16. 4 plus 16 is equal to 20. So this is equal to the square root of 20. Now square root of 20. 20 can be expressed as 4 times 5 because 4 times 5 is equal to 20. Now if you want to simplify this set, normally what we do is that we search for two factors in such a way that one is a perfect square. We search for two numbers. When we multiply, you get 20 in such a way that one is a perfect square. So 20 can be expressed as 4 times 5. Now the square root of 4 times 5 is equal to the square root of 4 times the square root of 5. When we take the square root of 4, the answer is 2. So we have 2 times the square root of 5. That is 2 root 5. So the magnitude of PQ, the magnitude of the vector PQ, that is 2 minus 4 is equal to 2 root 5. Now let's look at addition and subtraction of vectors. Given the vectors, we are given two vectors. We have vector A, the coordinates are x1, y1, and vector B, the coordinates are x2, y2. Now with addition of vectors, if we are adding vector A to vector B, then we have A plus B equals, vector A is x1, y1, so we have x1, y1 plus vector B is x2, y2, so we have plus x2, y2. Now with addition of vectors, we add the corresponding element, that is x1 plus x2 and y1 plus y2. That means that A plus B, which is equal to x1, y1 plus x2, y2 is equal to x1 plus x2 then y1 plus y2. That is how we add vectors together. Now, given A equals x1, y1 and B equals x2, y2. Now let's look at how subtraction of vectors goes. A minus B will be equal to x1, y1 minus x2, y2 because A is x1, y1 and B is x2, y2. So because we have A minus B is equal to x1, y1 minus x2, y2, and this is equal to x1 minus x2, y1 minus y2. That is x1 minus x2, y1 minus y2. That is how we subtract vectors. Now example, if A equals 3 minus 4 and B equals 5, 6, then A plus B is equal to 3 minus 4 plus 5, 6. How do we add these vectors together? We add the corresponding entries. That is the x coordinate of the vector A is added to the x coordinate of the vector B. So we have 3 plus 5. Then we also have minus 4 plus 6. Now 3 plus 5 is equal to 8. And minus 4 plus 6 is equal to 2. That means that A plus B is equal to 8, 2. Now A minus B. We are now subtracting B from A. Vector A is 3 minus 4. And vector B is 5, 6. So if you are subtracting 5, 6 from 3 minus 4, then we have 3 minus 5, and that is 3 minus 5. Then we have minus 4 minus 6, and that is how come we have minus 4 minus 6. Now 3 minus 5 is equal to minus 2, and minus 4 minus 6 is equal to minus 10. This means that A minus B is equal to minus 2 minus 10. Now let's look at the position vector. We have the y-axis, we have the x-axis. This is the intersection of the y and the x-axis. That is the origin O. Now considering the point on the graph A, A1, A2, The x coordinate is a1, and that is a1 on the x-axis, and the y coordinate is a2, that is a2 on the y-axis. Now the position vector of the point A is given by OA, is given by vector OA, which is equal to small letter a, and this is equal to a1, a2. So with the position vector form, we have our x coordinate up, then we have our y coordinate down, instead of the coordinate separated by the comma. This is the coordinate form, and this is the position vector form. So if you have a point A, a1, a2, then if you want to express the coordinate, that is point A, in the position vector form, it is OA, which is the same as small letter a, and this is equal to a1, a2 as shown. Now expressing two given points as a vector. Assuming that you are given 2 points and you are asked to express the two given points as a vector, how do you express two given points as a single vector? Now we have point A on the graph, that is a1, a2, and we have point B also on the graph, b1, b2. Now you can see that, assuming you are traveling from A to B, assuming you are traveling from the point A to the point B, there are two directions that you can take. Either you move from A to B straight forward, or you decide to make a transit, that is, you move from A to O, and finally you move from O to B. At the end of the day, you still get to the point B. Now you can see that OA is the position vector, that is A, indicated by the arrow, that is the direction. And OB is the position vector, also indicated by the arrow. Now AO, that is assuming you want to move from A to O before you move from O to B. AO means that you are going opposite to the direction of A. Because OA equals A, it means that AO will be the negative of the vector A. So AO will be minus A. Then from O to B, because you are traveling in the same direction, it will be plus B. That means that moving from A to B, that is AB, is the same as minus A plus B. The reason why it's minus A from moving from A to O is that we are going opposite to the direction of the vector as shown by the arrow. And so AO equals minus A, but OB equals B. So from the diagram, we saw that AB, vector AB is equal to AO plus OB. And AO is minus A, because that is opposite to the direction of the vector A, plus OB, that is B. Minus A plus B can also be written as B minus A. And you know that the small letter b represents position vector of the point B, and the small letter a represents the position vector of the point A. This means that AB, that is vector AB, is equal to position vector of B minus position vector of A. Now find the vector AB if A equals 3 minus 2 and B equals minus 1, 5. We know that the vector AB is equal to B minus A. From the diagram, we saw that vector AB is equal to B minus A. Vector B has been given to be minus 1, 5. And vector A has been given to be 3 minus 2. So B minus A will be equal to minus 1, 5 minus 3 minus 2. Now we are now subtracting vector 3 minus 2 from minus 1, 5. And how do we subtract? We have minus 1 minus 3. That is minus 1 minus 3. And we have 5 minus 2. Now minus 1 minus 3 is equal to minus 4. And 5 minus 2 is equal to 5 plus 2. That is because the coefficient of the bracket is 1. Minus 1 times minus 2 will give us plus 2. That means we have 5 plus 2, and 5 plus 2 will give us 7. So vector AB, which is equal to B minus A, is now equal to minus 4, 7. So we see that the vector AB with the vector A to be 3 minus 2 and vector B to be minus 1, 5 has now been expressed as a single vector minus 4, 7. That is how we express two vectors as a single vector, or 2 points as a single vector. Now we are going to look at the midpoint of a line segment. The midpoint of a line segment. Considering this diagram, AB is a straight line. AB is a straight line. Let M be the midpoint of A and B. That means that M is the center of the line AB. So M is the midpoint. OM is the position vector of M. OA is the position vector of A. And OB is the position vector of B. And the position vector of O, the position vector of A, that is OA, is the same as small letter A. The position vector of M, that is OM, is the same as small letter M. And the position vector of B, that is OB, is the same as small letter B. Now, if M is the midpoint, when we look at this diagram, we can see that the distance from A to M is the same as the distance from M to B. Why? Because M is the midpoint. M is the midpoint. So vector AM is equal to vector MB. Now, if vector AM is equal to vector MB, then how do we express this? Take note that vector AM is the same as M minus A. And this is equal to vector MB is the same as B minus M. Vector AM is the same as M minus A. That is the second element minus the first. We have M minus A, and this is equal to vector MB is the same as B minus M. Now, we are solving for M, that is the midpoint. So minus M on the right hand side becomes plus M on the left hand side, and that is how come we have M plus M. And this is equal to minus A on the left hand side also becomes positive A on the right hand side. So we have A plus B because already we have B on the right hand side. M plus M will give us 2M. And this is equal to A plus B. Because we are solving for M, we need to divide the left hand side by 2. And we divide the right hand side also by 2. Dividing the left hand side by 2, we are left with M. And dividing the right hand side by 2, we have A plus B over 2. So we can factor half out and we have A plus B in brackets. This is the formula we are going to use in calculating for the midpoint of a line segment. M is equal to half A plus B, where A is the position vector of the point A and B is the position vector of the point B. So when you add the position vectors together and you take half of the results, that will give you the midpoint of the line joining A and B. That will give you the midpoint of the line joining A and B. Now example, if T is the midpoint of AB, if T is the midpoint of AB, where A is 4, 6 and B is 5 minus 2. So these are the 2 points. We have A to be 4, 6 and B to be 5 minus 2. And we are supposed to find the midpoint. From the question we are told that T is the midpoint. And so solution. We know that the midpoint T will now be equal. Take note that it is not M equals half AB, A plus B. It is rather T, because from this question we are told that T is the midpoint. So make sure you use whatever you are given. Now if T is the midpoint, then it means that the position vector of T will be the small letter t. That is why it is T equals half of A plus B, where A is the position vector of A and B is the position vector of B. So now the position vector of A, that is 4, 6, is given by 4, 6. That is A equals 4, 6. And the position vector of B is given by 5 minus 2. That is how the position vectors are written. These are the coordinate form and these are the position vectors form. Now We know A equals 4, 6 and B equals 5 minus 2. So T equals half A plus B. Now T will be equal to half. A is now 4, 6 plus B is now 5 minus 2. So this is equal to half. Now 4 plus 5. We have half of 4 plus 5. Then 6 plus minus 2. Now when we add 4 to 5, the result is 9. And 6 plus minus 2 is equal to 6 minus 2. That is 4. So we have half of 9, 4. And half of 9 equals 4.5. And half of 4 equals 2. That means that the midpoint, the position vector of the midpoint, that is T, is equal to 4.52. 4.52. Where 4.5 is the x-coordinate of the midpoint and 2 is the y-coordinate of the midpoint. Now, let's consider the magnitude and the direction of a vector. We consider the magnitude and the direction of a vector. We know that bearings measure rotation in the clockwise direction from the north, from the positive y-axis. Bearings is the same as the direction. Now, when we are measuring the bearing from the north, that is from the y-axis in the clockwise direction, as indicated by the arrow. This will be our first quadrant, and this will be our second quadrant. This will be our third quadrant, and this will be our fourth quadrant. Now, these are the rules in calculating for the bearings in all the 4 quadrants. Now, when you fall in the first quadrant and you are calculating for your bearing, bearing is equal to 90 degrees minus theta degrees. Take note that theta degrees is the angle always with respect to the x-axis. So if you fall in the first quadrant, that is if your theta falls in the first quadrant and you are calculating for the bearing, then bearing will be equal to 90 degrees minus theta. However, if you fall in the second quadrant and you are calculating for the bearing, then the bearing equals 90 degrees plus theta. If you fall in the third quadrant, bearing is equal to 270 degrees minus theta. And when you fall in the fourth quadrant, bearing equals 270 degrees plus theta. So these are the rules used in calculating for bearings in all the 4 quadrants. Take note of this. Now, example. Express vector AB as a directional vector if vector AB equals 4, 3. If vector AB equals 4, 3. Now, we are also giving vector PQ to be 4 minus 3. We are giving vector MN to be equal to minus 4 minus 3. And IV, we are giving vector SR to be minus 4, 3. Now, let's look at how best we can express these given vectors in the directional form. Now, solution. From the vector AB was given to be 4, 3. The x coordinate is 4 and the y coordinate is 3. So we have 4 on the x axis and we have 3 on the y axis. But the distance on the y axis is the same as this distance. This is the distance. So we have 3 and we have 4 on the x axis. Now, given vector AB to be equal to 4, 3, we first have to find the magnitude, and we know that the magnitude is equal to the square root of the x square plus the y square. X coordinate is 4 and the y coordinate is 3. So we have 4 square plus 3 square. And 4 square equals 16, 3 square equals 9. 16 plus 9 equals 25. And the square root of 25 equals 5. That means that the magnitude, that is the distance from A to B, is equal to 5. Now let's calculate the bearing. Let's calculate for the bearing. Before we can calculate for the bearing, we first have to calculate for the angle theta. That is the angle with respect to the x-axis. Now, when we consider this right angle triangle, theta is an acute angle. Theta is opposite to the side 3 and adjacent to the side 4. So we know the opposite and the adjacent. So we use the ratio tan theta. Tan theta is equal to 3 over 4. And 3 divided by 4 is equal to 0.75. How do we find theta? We have to take the tan inverse of both sides. And so taking the tan inverse on the left hand side, we are left with theta. And on the right hand side, we have tan inverse of 0.75. And tan inverse of 0.75 is equal to 36.9, which is approximately equal to 37 degrees. That means that the angle theta, that is the angle with respect to the x-axis, is 37 degrees. Take note that bearings measure rotation from the north in the clockwise direction. And because we are in the first quadrant, how do we find the bearing? Bearing equals 90 degrees minus theta, and now the theta is 37 degrees. So we have 90 degrees minus 37 degrees, and the answer is 053 degrees. That is the same as 53 degrees. Hence, vector AB is equal to 5053 degrees, where 5 is the magnitude, and 53 degrees, that is 53 degrees, is the bearing. So this is the directional vector form of the vector AB for 3. Now, we consider vector PQ. Vector PQ has been given to be 4 minus 3. 4 is the x coordinate, so we have 4 on the x. And minus 3 is the y coordinate, so we have minus 3. Take note that the sign will only take you to the quadrant, but when we are calculating for the angle, we ignore the sign. So 4 minus 3, 4 is an x coordinate, and minus 3 is a y coordinate, so we have the minus 3 on the minus y axis. And that is the 3, because we don't consider the sign when we are calculating for the angle. Now the first thing we do is to also find the magnitude. So the magnitude of PQ will be equal to the square root of 4 square plus minus 3 square, and this is equal to the square root of 16 plus 9. This is equal to the square root of 25, and the answer is 5. Now we are finding the angle theta. Considering the angle theta, theta is opposite to the side 3 and adjacent to the side 4. So tan theta will still be 3 over 4, and the answer is 0.75. So if you want to find theta, you take the tan inverse of the right hand side. And tan inverse of 0.75 is equal to 36.9. That's approximately equal to 37 degrees. Now the bearing is equal to 90 degrees plus 37 degrees. If you are in the second quadrant, your bearing will be 90 degrees plus the angle theta, that is 37 degrees. And this is equal to 127 degrees. Hence, PQ is equal to 5,127 degrees, where 5 is the magnitude, that is the distance, and 127 degrees is the bearing. That is from the north to where we touch the line. That is from the north in the clockwise direction. Now, considering vector Mn equals minus 4, 3, we also find the magnitude. That is the square root of minus 4 square plus minus 3 square. That is minus 4 square plus minus 3 square. Minus 4 square is 16, and minus 3 square is 9. So we have 16 plus 9, that is 25. And the square root of 25 equals 5. Now looking at the angle theta, take note that minus 4 is the x coordinate, so that is on the x axis. And minus 3 is the y coordinate, that is on the negative y axis. So the minus 3 is here. But when we are calculating for the angle theta, we don't consider the sign. The sign will only take us to the quadrant. So both the x and the y are all negative. That is why we are in this quadrant. Because in this quadrant, the x is negative and the y is also negative. Now, 3 is opposite to the angle theta and 4 is adjacent. So we use the ratio tan theta equals 3 over 4. The answer is 0.75. How do we find tan? How do we find theta? We have to take the tan inverse of the right hand side. And that is tan inverse of 0.75, and the answer is 36.9 degrees. This is approximately equal to 37 degrees. Now, bearing is equal to 270 degrees minus 37. That is minus theta degrees. And theta is now 37 in this quadrant. And in this quadrant, if you are calculating for the bearing, it's 270 degrees minus 37 degrees. That is minus theta degrees. And this is equal to 233 degrees. Hence, Mn is equal to 5,233 degrees, where 5 is the magnitude and 233 degrees is the direction or the bearing. Now, considering vector SR equals minus 4, 3, we need to find the magnitude first. And so the magnitude of SR will be the square root of minus 4 square, that is the S coordinate square, plus 3 square, that is the Y coordinate square. Minus 4 square is 16, and 3 square is 9. Now 16 plus 9 is equal to the square root of 25. The square root of 16 plus 9 is equal to the square root of 25, and the square root of 25 equals 5. Now, when we consider this angle theta, 3 is opposite to the angle theta, and 4 is adjacent. So we have opposite over adjacent. So still, we use the ratio tan. So tan theta is equal to 3 over 4, and 3 over 4 is 0.75. So if you want to find theta, theta will be equal to the tan inverse of 0.75. And the answer is 36.9 degrees, which is approximately equal to 37 degrees. Now, in this quadrant, when you are finding the bearing is 270 degrees plus theta. And now the theta has given us 37 degrees. The theta has now given us 37 degrees. So instead of 270 degrees plus theta, we have 270 degrees plus 37 degrees. And this is equal to 307 degrees. This means that SR is equal to 307 degrees, where 5 is the magnitude and 307 degrees is the bearing or the direction. Now let's look at how we can express a directional vector as a column vector. If a vector has magnitude of m and is on a bearing of theta degrees, the required column vector is therefore written as m sin theta, m cos theta. That if you have a vector and the vector has a magnitude of m and is on a bearing of theta degrees, if you want to express that vector in the column form, is given by m sin theta, m cos theta. That is the magnitude times the sine of the bearing. Then the y coordinate will be m times cos of the bearing. So we have m sin theta, we have m cos theta, where m is the magnitude and theta is the bearing. So the s coordinate will be m sin theta and the y coordinate will be m cos theta. Now example, express u 20,300 degrees as a column vector. How do we express this as a column vector? U can be expressed as 20 sin 300. That is 20 sin 300. That is the s coordinate. And the y coordinate will be 20 cos 300. Now 20 sin 300 will give us minus 17.32. And 20 cos 300 degrees will also give us 10. That means that u is equal to minus 17.32 and 10. This is the column vector of this directional vector. So that is how we express a directional vector as a column vector. It is the magnitude sine the bearing. So 20 sin 300, 20 cos 300. And the answer is minus 17.32 and 10. Minus 17.32, 10. That is the column vector. This is the end of our presentation.